Hello viewers, in today's class we are going to discuss yet another important problem from definite integrals, right? So let us start. Now here we have to evaluate this integral which is from 0 to pi by 2 square root of sine 2 theta sine theta d theta, right? Now let us first call this integral as I, right? Now here what we will do, will use an important property of definite integrals, and the property is integral from 0 to a f of x dx is equal to 0 to a f of a minus x dx, right? Now here what we will do, will replace this x by a minus x. Now if we compare this integral with this one, then we see that the value of a is pi by 2, right? So now this integral I can be written as 0 to pi by 2, and in this integrand will replace theta by pi by 2 minus theta, right? So now this integral 1, it becomes a square root of sine 2 pi by 2 minus theta, and here we have sine of pi by 2 minus theta, and here we have d theta, right? So what we have done, we are given this integral, and we are using this property, and we replace theta by pi by 2 minus theta, because here we have to replace x by a minus x, right? So now simplifying it, we have 0 to pi by 2. Here we have a square root of sine, multiplying these two terms by 2, so we have pi minus 2 theta, right? And here sine pi by 2 minus theta is cos theta, right? So from trigonometry, sine pi by 2 minus theta is cos theta. Now this integral can further be written as 0 to pi by 2, and we know from trigonometry that sine pi minus theta is sine theta, right? So here we have sine of 2 theta, and here we have cosine theta d theta. So now this is integral number 2, right? Okay, so now we have two integrals, and what we will do, we'll add both these integrals, right? So now if we add 1 and 2, then we have I plus I in the left hand side, and here we have 0 to pi by 2, then we have a square root of sine 2 theta sine theta d theta plus this integral, right, that is 0 to pi by 2 and square root of sine 2 theta cos theta d theta, right? Now I plus I becomes 2I, and we can write these two terms as integral from 0 to pi by 2, and if we take square root of sine 2 theta common, then we have sine theta plus cos theta, right? So now we have to evaluate this integral. Now here what we will do, will make use of the method of substitution, right? So in method of substitution, what we will do, we'll put say t is equal to sine theta minus cos theta, right? So we'll put sine theta minus cos theta is equal to t, because the derivative of t is cos theta plus sine theta, which is present here, right? So therefore dt over d theta is equal to cos theta. The derivative of sine is cos, and the derivative of cos is minus sine, and we have cos theta plus sine theta, right? So now dt can be written as sine theta plus cos theta and d theta, right? So for this term we have dt, right? And further what we will do, will square both sides. Here squaring both sides, so what we will get, we have t square is equal to sine theta minus cos theta whole square, right? Because we have to replace this sine 2 theta by this variable t, so for this we'll square both sides. So t square is sine theta minus cos theta whole square, and this is t square sine square theta a minus b whole square, and here we have cos square theta minus 2 sine theta cos theta, right? And t square is now equal to sine square theta plus cos square theta is 1 from trigonometry, and 2 sine theta cos theta is equal to sine of 2 theta, right? Because sine 2 theta is equal to 2 sine theta cos theta, and now sine 2 theta can be written as 1 minus t square, right? Okay, so now we have dt is equal to sine theta plus cos theta d theta, and sine 2 theta is 1 minus t square. Okay, now here let us change the limits accordingly, because here here theta varies from 0 to pi by 2. So when theta is 0, then the value of t is sine 0 minus cos of 0, and sine 0 is 0 and cos of 0 is 1, so we have minus 1, right? And when theta is pi by 2, we have t is equal to sine pi by 2 minus cos pi by 2, and sine pi by 2 is 1, cos pi by 2 is 0, so we have 1, right? So when theta varies from 0 to pi by 2, then t, it varies from minus 1 to 1, right? So now this integral that is 2y, it becomes minus 1 to 1, and here we have a square root of sine 2 theta, and sine 2 theta is 1 minus t square, and for sine theta plus cos theta d theta we have dt, right? So now I can be written as half, and we have minus 1 to 1, and this term that is 1 minus t square can be written as 1 square minus t square, right? And here we'll use an important result from indefinite integrals, and the result is the integral of square root of a square minus x square dx is equal to x over 2 square root of a square minus x square plus a square over 2 sine inverse x over a, right? So here we'll make use of this result, and here if we compare this integral with this one, then we see that the value of a is 1 and the variable x is t, right? So now this integral I can be written as half, and we have the integral of square root of 1 square minus t square can be written from this result. So we have t over 2, then we have square root of 1 minus t square, here we can take square, and then we have 1 square over 2, and this is sine inverse t over 1, right? And the limits are from minus 1 to 1, right? So now if we substitute the limits, then the first term will be here, if we take t is equal to 1, then this term becomes 0, because here we have 1 square minus 1 square, so here we have 0, and here we have 1 over 2 sine inverse 1, right? And minus, and here we have when t is equal to minus 1, then again this term will become 0, and here we have 1 over 2 sine inverse minus 1, right? Okay, so now I can be written as half, and here we have sine inverse 1 is pi over 2 and minus, and here we have half, and sine inverse minus 1, we can take this negative sign outside, and sine inverse 1 is pi over 2, right? And now it can be simplified as pi by 4, and here we have plus pi by 4, right? And this is half, this is 2 pi by 4, and 2 and 2 get cancelled, and we are left with pi by 4, right? So viewers, the value of this definite integral is pi by 4.